Hello, everyone. Welcome to the dkNET webinar. I'm Koei Ling, and I'm the host of today's webinar. For those who are new to dkNET, dkNET is a research resource information portal founded by NIDDK. We provide several services, including resources and tools that support rigor and reproducibility. We also help researchers discover useful research resources and keep up to date on new tools and services. We have the Hypothesis Center to assist researchers in generating research hypotheses and fair data management services to help make your data fair. For more information, please visit dkNET.org. So before I start today's webinar, I'd like to go over a few housekeeping items. Please note that this webinar is being recorded. Please mute yourself during webinar presentation. I will collect the question. If you have any question during presentation, please use the chat function. I will collect the question and ask the presenter during Q&A session. After the presentation, we will have a Q&A session. So during that time, you are welcome to unmute yourself or use the chat function to ask any question you may have. Thank you for your cooperation. So today, it's our pleasure to have Dr. Jeffrey Grethe, who is the principal investigator of dkNET, join us and give us a presentation on Discover the Latest from dkNET, Biomed Resource Watch. Dr. Jeffrey Grethe is currently a principal investigator for the NIDDK Information Network, dkNET, and associate director in the Center for Research in Biological Systems at the University of California, San Diego. He received a Bachelor of Science in Applied Mathematics from the University of California, Irvine, followed by a PhD in Neurosciences with a specialization in informatics and computational modeling from the University of Southern California. After completing a postdoc training, a position at Emory University, where he worked with image technologies, Dr. Grethe transitioned to the University of California, San Diego as part of the Biomedical Informatics Research Network, BIRM, where he was the executive director of a BIRM Coordinating Center. Throughout his career, Dr. Grethe has been actively involved in fostering collaborative research, promoting data sharing, and driving innovation through advanced informatics approaches. His contributions have extended beyond dkNET to projects such as the Cyclone platform and the Open Data Commons for Spinal Cord Injury, ODC-SCI, and the Traumatic Brain Injury, ODC-TBI, and the SPARC. This project aimed to establish fair data platforms for researchers. So without any further ado, please join me in welcome today's speaker, Dr. Jeffrey Grethe. Jeff, over to you.
Thank you, Koei. So let me share my screen here. Okay. So as Koei mentioned, I'm going to be talking about Biomed Resource Watch, which is one of the newest components of dkNET. And, as Koei had mentioned, dkNET is, an information portal for biomedical researchers funded by NIDDK. And really, what we're trying to do is to connect, DK researchers to NIH resources and other resources that are out there that will help improve their research, either, as Koei mentioned, around rigor and reproducibility, or in terms of, finding, for example, the appropriate, reagents, antibodies for their work. The portal itself has a number of areas. What I'm going to be focusing on mainly is these two on the top really align with Biomed Resource Watch. And so that is information about research resources that dkNET provides. We also have information about fair data and the new data management sharing plans, which are an important part of the scientific process in terms of sharing your data, and also for the new mandates which just came out this year. So if if you have any questions about that, please don't hesitate to come to dkNET to find out more there. And then information about available data, and also generating hypothesis from some online tools that have been built around data. So Through the portal itself, if you look at the top left box here, that's where we have the information about finding resources to help power your research, and this includes tools, cell lines, antibodies, organisms, plasmids, and more. And these tools, are available at different stages of the sort of the research life cycle. And so, when you're planning an experiment, these tools become important, especially the resource reports and authentication reports in terms of developing, your new research plan, around the study, what resources are reliable, which resources should be used, generating authentication reports that NIH requires, what are the ways that, you need to actually validate those resources that you're using. So again, these are tools that can really help in, the research process that you are undergoing. So the key thing that drives our ability to have information about resources is unique identifiers. So unique identifiers are critical in the identification of these key biological resources. And so these are the research resource identifiers. And so in a number of years ago, and even today, if you go into a journal and you look at, for example, what organism was used in a study, you get some text, and that it was purchased from Jackson Laboratories. If you actually go to the site, sometimes you can't find that because, again, writing about, a reagent or an organism is different than, identifying it, especially with a critical identifier. And so this was actually quite common. So in 2013, Vasilevsky and others sort of looked at, what is the ability to identify resources, in the literature. And for many of them, it was, hit or miss in terms of being able to identify, resources in papers. And so this is why the research resource identifiers, RIDs, were introduced. They were introduced to be unique identifiers for research resources, so persistent identifiers that could be used in the literature, to uniquely identify, what was used, as part of a protocol in a study. These identifiers are also search friendly. So, for example, you can go to Google and Google Scholar, and you can search for these identifiers very easily. And they're also provided by independent community registries. So there's no one source that is generating these identifiers. These identifiers are being generated by, the actual resources in the community that are providing these resources. So it really is a sort of a community based effort in terms of the production of these identifiers. And then resources such as dkNET are actually able to aggregate that information and provide information about those resources. And so what you'll notice is that on the right, the RID is very simple. The RID colon tells you what type of identifier it is. The next bit, AB, tells you, what community authority, has issued this identifier, and then the underscore and the identifier itself. So this is very similar to other identifiers, such as the digital object identifiers you see when you're publishing papers. And you have, the first part, again, is DOI, colon, and then the next part will actually be the journal or the publisher, and then there'll be a slash, and then there'll be the identifier from that journal or publisher. So again, it's the same identifier model used for many different types of identifiers. And so these RIDs, really allow us then to track, for example, who used certain resources, which is important in terms of finding out information about how those resources perform, and then also, are useful in rigor and transparency. So being able to basically uniquely identify these antibody cell lines, for authentication and for other validation needs. And so there's been significant growth of RID adoption. So they're in use across major publishers, so Cell Press, Elsevier, Wiley, Nature Science. They've been included in a number of standards, including the JAT standard, which is a standard for how publishers provide information to PubMed. And so that is, an important inclusion there of RIDs there. And they've also been included now in a number of different checklists, for publication. One is the Material Design Analysis Reporting Checklist for authors, and they're also part of the new Arrive Essential 10 reporting checklist. And so in the literature, there are 90,000 distinct resources that have been identified with RIDs. There are over 600,000 citations in the literature, and the services around RIDs, the usage of these services continues to grow. As we mentioned, there are a number of these checklists and journals that have, are promoting the use of RIDs. For example, the Cell Press Star Methods as well is another one where, the RIDs, are used. In addition, RIDs are now being requested in a number of RFAs as well. Again, so this is, as the use of RIDs becomes more common, this is something that you'll be seeing more and more of in terms of needing to use these identifiers. So what happens when we do have a number of we have these persistent identifiers available? As I mentioned earlier, that really allows us then to sort of develop an ecosystem around these key biological resources. So at dkNET we provide these resource reports, right? So if you search for an antibody or a model organism, you'll get back a report about information about that resource. So essential information about the antibody. We then can, we have, for example, then usage and citation metrics, potentially finding collaborators, people who have used this antibody that may be near you, and then also looking at, performance information. So, for example, here we notice that this antibody has validation information available at the ENCODE project. So again, this is a report that's been brought together with information, from a number of different resources, and this is what the RIDs power. So, for example, the citation and usage metrics. Since we now have the RIDs embedded in the journals, we can actually then use those RIDs. We can scan for them in publications, and we can start generating metrics around usage, and also point people to the latest papers that use that resource, but also what other resources were used in the same studies, right? So for antibodies, there other antibodies that were used in the similar study. What tools were used to analyze the data generated by the study. So again, we can pull that type of information now from the literature through the use of these identifiers. And when one looks at sort of the overall landscape of where these RIDs now can provide information, we're really talking about how we can make resources fair. So if you've been looking at the new data management sharing plan mandate, and data sharing guidelines, there's a lot of talk about making data fair. So fair really talks about F for findability, A for accessibility, I for interoperability, and R for reusability, right? And fair, as we see it, is not just for data, right? It's also about this information, right? So findability is really driven by the unique identifiers, right? So can you find information using those unique identifiers? And a resource like dkNET then provides an index of all these RIDs, so it's easy for you to retrieve information about them. And that gets to accessibility, and then interoperability, the identifiability of those resources, really looks at aggregating information across a number of different information sources. So we have, again, community resources with information about these resources that we pull information from. I've already mentioned the literature, where we're actually able to go in and scan using natural language techniques and other techniques to pull information about what RIDs, are represented, in which publications. But then also there are a number of different projects. So, for example, the ENCODE project, the Human Protein Atlas, are example of projects that provide information about, antibodies, and have that information, that can be linked to. And so these RIDs allow this aggregation of information, and from all this information in the literature and, the external resources, we are actually able then to provide alerts to researchers themselves. And one of the main thing, that, we have to worry about is, problematic research resources. So, there are estimates that, problems with reagents in the literature have been estimated to cost NIH, a large amount of money, as papers, are not reproducibility, continue to come into the scientific literatures. And if key reagents such as antibodies, in the literature can be tracked down less than 50% of the time, that is a critical issue. And so, the problematic research resources, how does one get this information about these resources to, the investigator? And so, the RIDs, just through, having to publish RIDs, with your manuscript, you are taken to a site, that has information about potential issues, with, for example, cell lines. Right. So if one, study was done in 2019, where Babak et al. Looked at, how many papers have cell lines on the problematic list if they did not use RIDs versus those that used RIDs. And there's a great decrease in the number of cell lines used in papers, that have RIDs. And so again, having an information resource that provides this type of information to the researcher, provides sort of this, again, the central clearinghouse of information. So, you have to, go through this resource to get your RID, and then you're provided information about, the resource, potentially has impact, on, the use of those problematic resources. And again, there are a number of different places where this information comes from. So for cell lines, the community authority that is responsible for providing information on cell lines is Cellosaurus. And they actually also collect information from the International Cell Line Authentication Committee, which provides information on problematic cell lines. And so again, from some of the community authorities, we're actually also bringing in, some of this information about the resources. And then, as I mentioned before, there are, the Human Protein Atlas, for example, has, information on validation data, and, some actual projects and other consortia. For example, the Intestinal Stem Cell Consortium also has, for example, information about various resources. And so that brings us to Biomed Resource Watch. So how are we able to then more efficiently aggregate this information? And so because that was a need within the resource reports and other tools that dkNET was offering, we saw the need to basically start a resource that is able to effectively and efficiently bring this information together. And so that's what Biomed Resource Watch's goal really is the aggregation of this information about key biological resources. And so Biomed Resource Watch allows for the aggregation of this data from various resources. And we've also added the ability to provide, the ability for users and the community to contribute to Resource Watch directly, as well as to take information from advanced text mining, algorithms. And so when you go to Biomed Resource Watch and you look at, one of the resources, we have information on the resource itself on the left-hand side of the page, and on the right-hand side, you'll see either validation information and issue information about that resource provided. And so through Biomed Resource Watch, building on what we had done initially, bringing in information from the community authorities and a few projects like ENCODE and the Human Protein Atlas, we are now expanding, the ability to bring in, information to this resource information network, from other sources. And so one of them, as I mentioned, was the natural language processing. And so as part of dkNET, we've actually developed a text mining pipeline for antibody specificity, within the literature. And so this is, some of the content, that has been brought into Biomed Resource Watch. And so, these are important tools, especially as, natural language processing, AI methods become, more powerful. In terms of, providing, the resource validation and performance information, again, the pages are really set up to focus on, as the example before was validation information, and here what we see is on the left we see the issue information. So, for example, here is a cell line, that has the information cell source and information about that this is a problematic cell line, potentially contaminated. And then we also, have information that, the cell line has been discontinued, from one of the manufacturers. So again, trying to provide, as much information as we can aggregate around these resources. One of the other groups that we're most recently partnering with is Icaros. And so they are an open science company whose mission is to characterize commercially available antibodies, for every human protein. And so they directly work with vendors as their partners in characterizing, large numbers of antibodies. And so we have begun the process of, incorporating this information, into Resource Watch, and then this will also tie back to the reports that they publish, and they publish full PDF research reports, on their characterization through Zenodo. And so these are, in a sense, open access journal articles about, the performance of various antibodies. And so being able to, bring in, this information, from various resources, various new centers. And so in addition to Icaros, we've been bringing in also data from the Spark project, from Caribou, from other resources, and allow us to, in a sense, bulk upload, this information, into the resource itself. And so, when you look at the current distribution of information, we have a large amount of information from the antibody registry and from Cell Source, which are two community authorities. But this other slice of the pie is going to continue to grow, as we bring in more data, around these resources. Within dkNET, resource reports, we've also now linked, Biomed Resource Watch into these resource reports. So if you're looking at, a resource report, you'll see that you're now able to directly report information or view information, about this resource, at Resource Watch. And as I mentioned, we are allowing contributions from researchers themselves. And so we allow contributions about antibody cell lines and tools such as software. And it's easy to do this. You find the resource that you are trying to provide information on, and then there's a simple form that gets filled out, and you upload supporting documents. And so the supporting documents are a crucial feature in that Biomed Resource Watch, what we're really trying to be is sort of a neutral provider of information about resources. And so, we rely on, proper supporting documents, about the performance, of a particular resource. So, for example, a published paper, a white paper, that is developed in the lab, about, the performance of a very, of an antibody, for example. So this, any type of contributions need to be accompanied by, appropriate supporting documentation. And so this, again, is a simple form, that one goes through. So there's, full submission instructions, and, you basically can select what type of information you're providing and then the supporting documents that you'd like to provide. And this then goes to a curator dashboard. So we do have a curation layer on top of this to ensure that all the information that's been brought, that's being contributed by the community, is well documented. So what we're really looking for is that this is a true submission about a resource, and that it has appropriate supporting documentation with it. So again, I'll give you a quick walkthrough of Biomed Resource Watch, in terms of, again, how one might interact with the system. And so, from the front page itself, you'll see that there is a way to enter the RID for a resource that one can go in and look for. Resource Watch, once you hit the search button, will take you to that page around the resource. On the bottom, we do have some links to helpful information and tutorials, information about what is an RID, how to search for this information, how to get an RID for a resource that you might have, how to submit this information, and also then, if you're logged in, provides a link to view submissions that you have provided. So once we go to the Resource Watch page itself, you'll be provided the opportunity to make a submission. So there's underneath the resource information, there is a box where you can then report an issue or validation information for a resource. And below that is our disclaimer about the curation team activities. We ask that you confirm this, that this is the resource you are trying to provide information on. Once you confirm that, again, you're taken to this form. And so, for example, if you have an antibody that you're providing information from, you have 3 potential submission types available to you. You can provide validation information, you can provide information on an issue, or you can provide information that an antibody has been discontinued by a manufacturer. And then the various types of supporting documentation we can take are PubMed ID or DOIs to that refer to research papers, or other papers in the literature, such as preprints. URL if it's a link to potentially an external resource, such as a manufacturer that talks about the discontinuation of an antibody, over another resource. And then we also allow upload of PDF and images. So if you have an internal report from your lab, about the performance, of a resource, then you can upload that PDF as well. As we mentioned, you can tie directly from dkNET itself. So if you're looking for, a resource, looking for its RID, you are probably doing that through the dkNET resource report. So instead of then having to go directly to the Biomed Resource Watch and input that RID, you link directly from the resource reports, and then we will ask you again to log in to provide this information. So all this information that is provided through Resource Watch by the community needs to be associated with a login, and so you can use your same dkNET account, to log in to Biomed Resource Watch and provide that information. And again, then you'll end up at the same resource form as as I just described earlier. So again, those are the very simple pathways to engage with Biomed Resource Watch. So I hope this overview of Biomed Resource Watch will provide you the ability to come check it out. Contribute information, point us to information about these resources, because we believe, that the more information that we can aggregate around these research resources, the better, is better in terms of improving, research down the line, as people know more and more about, the resources that they're using. So Grethe, I guess we can transition to any questions.
Yeah, so now is our Q&A session. So if you have any question, you can unmute yourself, and I'm going to post the portal link in the chat. Okay, let me take a look. So there was a question from the audience. If I want to submit any information about the resource, but I can't find the resource in the resource report, or I can't find the RID for that, what should I do next?
Right. So first step is potentially to contact us, right? So at the bottom of our web pages, we do have a little a little help pop up, where you can send us a message about that. Usually if the RIDs are not found, for example, for antibodies, we will then work with whoever's using that antibody. We will work with them to ensure that it gets registered at the antibody registry, or if it's a model organism, can point to the model organism resource, that would be responsible for registering those identifiers. So it does happen time to time, and then as I mentioned, we do work with the community authorities to ensure that that those RIDs get appropriately registered.
Okay, thank you. The next question is, if I want to find an antibody with validation information available, do you know where can I do this?
Yeah, so when one does a search in dkNET for the resource reports, there is actually a facet. So you can select a facet on the left side of the portal, that will return resources that have validation information.
Thank you. The next question is, check. Can I contact the submitter to ask more questions in Resource Watch?
So we do have the information about who submitted the information. So again, these are public, just like any publication. So just as if there's a research publication that's highlighted in PubMed, there's you can contact the author of that contribution. I mean, so again, we publish this information just as a research paper is published, or a preprint is published.
Okay, thank you. There's one question coming. If I have several antibodies that I would like to submit, is there a way for me to upload them easily?
Yeah, so for the community contributions, for individual investigator contributions, currently we are doing that via the form itself. But if you do have a larger set of resources that you'd like to provide information on, you would contact us, and we would make sure that one of our curators work with you directly. to bulk upload, a larger collection of information. And this is the process that we're using, for, the external resources, such as Icaros that we're collecting information from.